It's my great pleasure to welcome Geoff Rayner-Canham this afternoon. For some reason I'm not seeing him myself, but Geoff, do you want to say something about yourself for 2 or 3 minutes while more people pile in? We've already got 42 people, so that's extremely good. Geoff, over to you.
Okay. Thank you, Peter. Myself and my colleague Marlene Rayner-Canham have been working on the history of women in science and particularly women in chemistry now for several decades. I teach at the Grenfell campus of Memorial University in Newfoundland, but I teach now by distance. So I'm actually speaking to you from Toronto, Ontario, Canada. I'm also doing the teaching at also occasionally at Nunavut Arctic College in the Arctic. So I'm pretty busy, in fact, and still writing books and still doing research on the history of women in chemistry.
Yeah. Okay, Geoff, are you ready to go now? So it's my great pleasure to introduce Rayner-Canham, who is our speaker this afternoon, and he's going to be talking about 12 pioneering women chemists you should know about, but probably don't. Geoff is going to enlighten us. Over to you, Geoff.
Okay, thank you again, Peter. This is a collection of 12 eclectic stories, and there's no linking factor apart from the fact that they're interesting women chemists, and maybe you know some of them, but I suspect you don't know all of them. So, a little bit about the background to get started. Marlene is my spouse and also co-researcher, and she's the one that loves burrowing around in archives and things, and I do the writing and I'm the front person for the talking. And we've been, say, working on this. This was one of our early books, Women in Chemistry, which was done for the American Chemical Society. They supported that. And the latest one, we got an award last year from the ACS for our work on the women in chemistry, and our latest book is this one, which is coming out shortly, Allies of Pioneering Women Chemists, which is different in that it focuses on 12 of the top British chemists of the past who had women in their research groups. And whereas you usually find the history of the British chemists as being that they were born, did all this research and died, we looked into what sort of personality these men had, why they tended to support women, and then the account of the women researchers who worked with them. So that's coming out very shortly. We've just done the page proofs. Simultaneously, as I mentioned, I'm still doing online teaching, and one of the courses with Debbie Wheeler at the Grenfell campus of Memorial University is an online course called Women in Science, which can be taken both as a gender studies course and as a general science course. And this has massive enrollment. We have to limit it, and it fills up usually on day one of registration. And so let's get started. And it's going to be primarily sort of on a chronological basis. And to say that it's just very interesting women chemists. First one, it's whether she should be called a women chemist or women scientist, but certainly one of the earliest. And this was Marie Murdrak. And she wrote a book, La chimie charitable et facile en faveur des dames, useful and easy chemistry for the benefit of ladies. And here's the cover of one of the editions. That's the second edition. The French editions came out between 1666, 1711, German editions 1673 and 1712, and there was an Italian edition. Interesting in terms of the illustration here, because it shows the curtain being pulled back to reveal knowledge, which was barred to women for so long. And she's particularly remembered not so much for the contents of the book, but her opening comments. I was tempted to publish it. I dwelt irresolute in this combat for almost 2 years. I objected to myself that teaching was not the profession of a woman, that she ought to remain in silence, to listen and to learn, without bearing witness that she knows. On the other hand, I flattered myself that I'm not the first lady to have something published, that minds have no sex, and if the minds of women were cultivated like those of men, and that if as much time and energy were used to instruct the minds of the former, they would equal those of the latter. So very stirring stuff for the end of the 1600s. And this book recently has become quite famous and cause for dispute, as to how much it was real chemistry, but certainly used the word chemistry, and she was certainly a pioneer. Here's a name that was forgotten till very recently, and she was truly the discoverer of the greenhouse effect. And the first, up until recently, it was John Tyndall of the Tyndall effect, who was credited with this, but in fact, she was far earlier. This was the paper she had published on the heat, circumstances affecting the heat of the sun's rays in the American Journal of Science and Arts in 1856. So what she did was to have glass cylinders full of different gases and put them out in the sun and study how their temperature changed. And she showed that carbon dioxide was unique in the amount of increase in temperature compared to the other gases. And this was what she wrote. The atmosphere of that gas, carbon dioxide, would give to our Earth a high temperature. And if, as some suppose, at one period of its history, the air had mixed with it a larger proportion than at present, an increased temperature from its own action must have necessarily resulted. So this was back in the 1850s, so very much experimental evidence for carbon dioxide as a greenhouse gas, or as a radiation trapping gas, as we'd say now. Now, this was recognized at the time. This was Scientific American. There's a cover from 1856. I'm not sure whether it's the exact issue, but it's certainly the same year. And they had an editorial. It's believed and taught by geologists that during the period preceding the Carboniferous era, that there was a very elevated temperature of the atmosphere in existence in comparison of that with the present day. Those who believe that this Earth was once a fiery ball attribute this ancient great atmospheric heat to elevated temperature of the Earth. In other words, all the heat, the reason why it was hot was because the soil and the rocks were hot. But Mrs. Foot's experiments attribute it to a more rational cause and leave the Plutonists but a small foundation to stand upon for their theory. So it was recognized at the time, then totally forgotten until this century, and rediscovered, and she's now duly attributed with the discovery. Julia Lermontova, pioneer woman in organic and organic chemist, Russian. And one thing people forget is that back in Imperial Russia's days, there were a lot of women scientists. This is a book authored by Mary Crease with contributions by Thomas Crease. The whole volume is devoted to Imperial Russia's women in science, 1800 to 1900, 22% of which were chemists. And they've been completely forgotten about from history. And so we picked upon Julia because her story is a particularly interesting one. So in those days, women could not go abroad unless they were either married and the husbands gave permission, or their families gave permission. And so she managed to escape Russia, chaperoned by Sofia Kovlevskaya. Kovlevskaya, a mathematician who some of you might have heard of, that she underwent a marriage of convenience so she could leave. And then she had brought along Yulia Lermontova as at the same time. So Lermontova entered University of Heidelberg, 1869, the same year she left Russia. And in 1870, she undertook research with Robert Bunsen on platinum metals, a topic suggested by Mendeleev. There's a younger picture of Mendeleev. He wasn't born with a big white shaggy beard, as some seem to think. Whoops. There we go. In 1872, she moved to Berlin and she undertook organic synthesis with von Hofmann. In fact, organic chemistry became a focus for the rest of her working career. And she was awarded a doctorate from the University of Göttingen. University of Berlin didn't give PhDs to women at that time. Then in 1876, she moved to Moscow and did research with Markovnikov. In 1877, she moved to University of St. Petersburg and she undertook research with Butlerov. So what we found particularly interesting is that she worked with all the great chemists of the time. Amazing story. And one of the things we've got to do now is to identify precisely what her research was and its contributions. But we do know that the reaction was named after the Butlerov, Elkakov, Lermontova reaction, which is shown there, the catalytic effect of a metal oxide for the insertion of an alkyl group. She then returned to Moscow and undertook research with Markovnikov again. And then after that, she went into the industrial field and worked on oil extraction techniques. And then finally, she adopted Kovlevskaya's daughter on Kovlevskaya's death. And that was the end of her career. And she raised the daughter Fufa and subsequently died. So amazing character in terms of being working with all these famous chemists of the period. Now, probably most of you, if not all of you, have heard of the Michaelis-Menten equation, but very few, I think, if you knew it was a woman scientist. And she was born in 1879, and she was raised fluent in one of the first natives languages in British Columbia because she grew up on one of the First Nations reserves. University of Toronto she went to, so across the country, did a BA, MB, and MD. And then she went to University of Berlin and worked with Michaelis, and that's where they devised the Michaelis-Menten equation. And just one point is the way that Central Europe, Germany, Switzerland was the go-to place for women scientists, women chemists, even from as far away as Canada. And in those days, of course, you couldn't just go to the airport and jump on a plane. This was quite an adventure for young women to undertake. And she was not a one-hit wonder like some people seem to think. She then went to the US because she couldn't get any further advancement in Canada at the time. And she did a PhD at the University of Chicago. And then in 23, University of Pittsburgh and Children's Hospital, became a surgical pathologist, post-mortem pathologist, and a hematologist. And just before she retired, she was granted full professor status, which she should have been given years and years before. So in 1950, she retired, but only briefly, because then she returned to Canada and became a cancer researcher, and then she retired again in 1955. So there's her in a car, one of the pioneer women drivers at the time around the US, and there's a later picture of her. And she was also renowned for her actual research. This, I believe, I'm not an expert in the area, is a test still used today, an azo dye test. And it says here, she Menten also conducted the first electrophoretic separations of blood hemoglobin proteins in 1944. In this, she preceded the results of Linus Pauling and his collaborators by several years. However, he is usually created with the discovery. And interesting insight into her personality, she Menten was made aware of every puzzling or interesting case submitted to Children's Hospital during her tenure. The pediatric residents flocked to the laboratory to consult her, and she was never too busy to listen. Marjorie Stevenson devised the field of bacterial microbiology. And this is a comment that I find very important. At the time when there were practically no women researchers in any other university departments at Cambridge, Hopkins That's Gowland Hopkins gave them place in his, despite the criticism which it brought him. And here's a picture of his 1916 research group. And as you can see, it's half women. In this particular one, Elsie Bully, Dorothy Jordan-Lloyd, Elfrida Cornish, and Muriel Welldale Onslow. So this was a point which comes back to the book which we just completed. Now, what's her contributions? Well, this was the book that was she wrote, and bacterial metabolism, and editions between 1930 and 1949, and it was reprinted right up until 1966 because of its superlative coverage of this field which she devised. Until she studied work, there wasn't no such field as bacterial microbiology. And I love this quote: perhaps bacteria may tentatively be regarded as biochemical experimenters, and we are in much the same position as an observer trying to gain an idea of the life of a household by accurate records of the food and commodities left at the door, patently examining the contents of the dustbin and endeavoring to deduce from such data the events occurring within the closed doors. So I really like that analogy of studying bacteria. Actually, see, it would be true today with people getting everything delivered to their door by Amazon or some food delivery company. Oops. And most important, that she was not really recognized. And in 1945, finally, she was one of the first 2 women elected as fellows of the Royal Society. And this was often regarded as a precursor for a British nomination for a Nobel Prize. Sadly, this was very late in her career, and she never was nominated for a Nobel Prize. But if you read her work and her contributions, it's certainly, in the view of biochemists, well deserving. Mary Polly Winnells Porter, pioneer woman crystallographer, and there she is. And why was she important? Well, one of the things was a comment from Dorothy Hodgkin. I wavered little in my determination to do crystallographic research for Part 2 chemistry. So I talked it over with H.M. Powell and also with Polly Porter and agreed to begin in September. Before that, Polly Porter advised me to go to Germany to work for a few months in the laboratory of Professor Victor Goldschmidt, a particular friend of ours. He designed a 2-circle goniometer for measuring crystals. Polly bought one of these for Oxford and also devised a good method of drawing crystals, which I learned. So Dorothy Hodgkin was really mentored to a certain extent by Polly Porter, who was not on anyone's radar till we did research on her. So a little bit about Polly Porter. She grew up in Rome, fascinated by the different marble compositions used by Romans for their building. Her parents refused her formal education, no formal education whatsoever, apart from reading and writing. She studied antique marbles in Oxford, at Oxford Museum when her family moved back to Britain, and she published her first book, What Rome Was Built With, Description of Stones Employed in Ancient Times for its Building and Decoration. And it's really amusing to read the reviews in the literature of this book, because they had no idea that it was a 21-year-old young woman who had got no professional training whatsoever, because they treated it as a wonderful treatise by some learned professor at a university. So this was her first publication. She was then tutored by Henry Myers, professor of mineralogy at Oxford. And long story, because she went off to US and did work there. Then she went to Germany and back again to Britain. She did lots of research, published widely. And she was appointed fellow of Somerville College, Oxford University, even though she'd never even graduated from high school. And she, as I mentioned, she mentored Dorothy Hodgkin, and it's very appropriate, and people don't realize it when they see this paper by Dorothy Hodgkin, this co-authored by an M.W. Porter. This was in 1950, and that was Mary Winnells Porter. And this was, she was 60-something at the time. And just because M.W. Porter, no one realized this was the Polly Porter that that actually was got Dorothy Hodgkin really interested in doing crystallography. And there's the goniometer that she brought back from Germany with her. Alice Ball, another forgotten person till recently, and she devised the first effective leprosy cure. So a little bit about her. She was educated in Honolulu to start with, and then her family moved to Seattle, and she graduated Seattle High School. She did a BS pharmaceutical chemistry at the University of Washington because up in the Northwest, things were much more liberal than they were in the South of the US. So she was able to go to a regular university, even though she was an African American. She got a BS in pharmacy at the University of Washington, and she did extensive research. This was one of her papers, and there's another one of her papers. And then she became an instructor in chemistry and research chemist at the University of Hawaii in 1915. And sadly, not long after that, she died in a lab accident. And the work was on chalmucric acid, and that's the formula of the acid. And this turned out to be the first effective leprosy cure. And as I mentioned here, Dean Ball's professor published the results without mentioning the work of Ball. This was after her death. It became known as the Dean method. And here's the actual article, The Treatment of Leprosy. As you can see that there's no mention in the title of Ball, there's no mention in the entire paper. And it's only very recently that it was realized that, in fact, it was Alice Ball who did all the work. And the neglect may have been due to both sexism and racism. And so this was 2023 when the work was really well appreciated. So only last year. And her work is recognized in Britain as well. I'm sure many of you are in London. And if you go to the London School of Hygiene and Tropical Medicine, along the top of the windows there, you will see Nightingale. Further over, you see Sklodowska-Curie, and right in the middle, that's Ball, that's Alice Ball, that's Augusta Ball. So her contributions are now finally being recognized. Rachel Fuller Brown, and we've had one on leprosy cures, and this is the first antifungal compound. And she did a BA in history, and she hated chemistry at school, which is still a common phenomenon when I teach, let's say, beginning chemistry, and people say, oh, I hated chemistry in school. All we did was to memorize the elements of the periodic table, and then we had to do weeks and weeks of calculations on limiting reagents and things, absolutely boring. And anyway, so she started BA in history because she loved history, and she was told you had to do a course in either chemistry or physics. And reluctantly, she chose chemistry, and that really turned her on to chemistry because it was with a very famous woman instructor, Emma Perry Carr, and that she decided chemistry was really what she wanted to do. And having been inspired, and so she then went and did a master's at the University of Chicago in organic chemistry. In those days, you really could flip BA in history and then an MS in organic chemistry. So then she did research with the New York Department of Health, and she was paired with microbiologist Elizabeth Hazen. And I love this quote. Thus, the collaboration began. Hazen, the microbiologist, slight, peppery, impatient, intensely active, and infinitely resourceful. Brown, the organic chemist, sturdy and a few inches taller, solidly dependable, seemingly imperturbable, and quietly powerful when necessary. It was an odd combination, but one that worked. And at the time, there was no antifungal. People would die of fungal diseases. They were a really severe problem. And so they were tasked with finding a good antifungal compound. And in the end, they did. And there's a picture of them in later life. An extracted and isolated nystatin, named after New York State. Many of you might have used it or under one of the trade names. So NYST, New York State. And there's the chemical structure of it. And they were very insistent this was not to be a money-making venture. If we had an antifungal that was useful, we were in some way responsible to see it was made available. So they found a non-profit company to produce it, and that any profits went to support young women scientists in their research and scholarships. And here's a tube of nystatin cream. Florence Bell, the first X-ray photo of DNA. I think this is taking some of you by surprise, that she was the one who took the first X-ray photo of DNA. And it's interesting because James Watson in the double helix made this statement. Fortunately, there already existed one half-good photograph of DNA in the published literature. It was taken 5 years previously by the English crystallographer W.T. Asprey and could be used to start us off. Now, Asprey was a polymer chemist who worked at Leeds looking predominantly at wool and other natural fibers. And but as usual, this is another example of the Matilda effect. He got recognized here by Watson, but it was not Asprey that did this. It was, in fact, Florence Ogilvy Bell. And in 1938, she was the one that actually teased out the strands of DNA and actually took the first X-ray photograph. And she was not just a lab assistant, that in 1935, she undertook crystallographic research with J.D. Bernal at Cambridge. In 1936, with Lawrence Bragg at the University of Manchester, and then Bragg persuaded her to go and work with Asprey, and that's when she went off to the University of Leeds and did this work. And this is a picture from the newspaper of the time, and slim 25-year-old Cambridge University graduate showing the people all about the X-rays and the work she'd been doing. And here is indeed the DNA photo, and this was part of a PhD research dissertation, was that the finding a way of taking a photograph, X-ray photograph of DNA and the photograph itself. And she's starting to get recognized. In 1941, she was drafted for war work, and the War Office would not consider her continuing with her research. They insisted that her war work was much more important. And she was assigned back off to the United States, where she married and discontinued her work. It's interesting, I found online this image. So she's finally getting some recognition. Here she is, paired up with Rosalind Franklin. Erika Kremer and gas chromatography. And Kremer was born in Munich in 1900. Her father, she was in a scientific family. Father invented glass electrodes for pH measurements, so very much a strong background in science. She was at University of Berlin in 1921. She worked on the hydrogen-chlorine chain reaction, not exactly the safest reaction to study, and it was so original it was allowed to be published under her name alone. In 1938, she qualified as university lecturer, but women were barred from academic positions by the Nazi regime. So she went to Austria, which of course was incorporated into Greater Germany, and at the University of Vienna, and studying gas mixtures. And it was the gas mixtures that got to look at ways of identifying the proportions of the components. And in 1944, she devised and published this, and had published in a German research publication, the construction of first gas chromatograph. Unfortunately, this was a time of heavy bombing, and the journal issue never actually appeared. In 1945, just as a sort of side thing, she was barred from access to university, and she had to smuggle herself onto campus in a delivery truck each day, and then smuggle herself off again. In 1952, Martin and Singer were awarded the Nobel Prize for the invention of gas chromatography. Her work had been completely overlooked and ignored, but in part, to be fair, that it was never properly published. And in a book that came out not so long ago, the posthumous Nobel Prize in Chemistry, Volume 2, Ladies in Waiting for the Nobel Prize, that women have been forgotten about in terms of the Nobel Prize. One of the chapters is Erika Kremer and the Origins of Gas-Solid Absorption Chromatography, 1944 to 1947. This brings us up more to date, and this is, I was ashamed that I'd not run across this name until it was pointed out by my colleague Debbie Wheeler. So she was she's still alive, a natural products chemist. And in 51, she grew up in rural China, attended Beijing Medical School, School of Pharmacy, and the China Academy of Traditional Medical Sciences. And in 1967, North Vietnam asked China for help in finding a cure for malaria. Apparently, in the Vietnam War, a lot of North Vietnamese soldiers were dying from malaria, not from fighting with the Southern forces and the Americans. So in 1969, China set up a task force led by Tu, and she surmised that there had to be knowledge dating back because South China also was afflicted badly by malaria throughout time. And so they investigated 2,000 traditional Chinese herbal remedies without success, just couldn't find anything that worked. And then she went back to the original source, the recipe and handbook of prescriptions for emergency treatments written in the year 340 Christian era. And she realized the difference because, as a good chemist, she knew that to extract stuff, you heat it up and boil it with water or some other solvent. But it turns out this compound is heat sensitive. You had to do a cold extraction. And this was how she managed to isolate the compound artemisinin, which was an active biomolecule against malaria. And then in 1 year later, she synthesized dihydroartemisinin, and it was even more effective against malaria. And in 2015, she was awarded the Nobel Prize in Physiology or Medicine, although really in a way it should be a Nobel Prize for chemistry, because it's chemistry is what she did, was the chemistry part of it. And I love this photo of all these guys in their penguin suits and her in the purple. And she actually was put on the cover of Time magazine. And the last one in this series was very, very coincidental because, as I mentioned, that Debbie Wheeler and myself co-teach every year the Women in Science course. And we had a student from Nigeria, and she says, wonderful how in the course it had women scientists from all over the world, but never one from Australia. And it just so happened I picked up Chemistry World, and there was a feature article on Marion Addy. And the timing couldn't be better. So Addy was now included in our course material. And I think she's worth discussing here as well. And she was born in rural Ghana. And then her family moved to Accra. She loved chemistry at school. And she got a BSc from the University of Accra, and then an MSc and a PhD from Pennsylvania State University. She got scholarships to go across the Atlantic in the opposite direction to the US. And after she graduated, she was made assistant professor at Howard University of Medicine. Now, this is in the South, and so this is a university for Black students. And so she then decided to come back to University of Ghana, where she was made professor. And this is where she did her research work, extracted bioactive compounds from the flowering plant Desmodium adcensins. And during the 1980s, with collaborators at Swedish and Canadian universities, the compounds proved to be a whole family of medicinal compounds, the soya saponids. And so there we are. But also she had another claim to fame. And this was that she became the first, she devised the National Science and Math TV quiz for Ghana TV. And she became the first quiz mistress in 2001. And there's Addie on the left, and then her successors, center and right. So she really made an impact, not just in the field of synthesis of bioactive natural products, but also in terms of publicity for science in Ghana. So I just wanted to do this quick overview, and I want to thank the invitation to present this historical group. You've been wonderful, and seeing as you're muted, you're a very quiet audience. So I thank the Royal Society of Chemistry. I thank the Grenfell campus, the small little campus on the west coast of Newfoundland, where I've worked for over 50 years, and is still as vibrant and as interactive as it was before. Just a nice place to be in, beautiful scenery, as you can see. And thank Marlene Rayner-Canham and Debbie Wheeler for working with me on many of these aspects. And if one of the questions is going to be, how do I find more about these women? The answer is that World Scientific have just signed a contract with us to actually write a book on 12, although that can increase to 15 pioneer women who have been forgotten about. So with that, thank you very much.
Okay, thank you very much indeed, Geoff. A fascinating talk, as always. My main, I suppose okay, I've got a couple of specific things, but firstly, do you think there are going to be many more women chemists who are going to be undiscovered? Because, of course, when you started, you were practically alone, and
Yeah.
therefore, every chemist you discovered was you discovered everywhere, and now you've discovered loads and loads of them. I'm just wondering, how many more do you think are out there waiting to be discovered, or don't you know?
No idea whatsoever, Peter. I mean, the discovery of Eunice Foote and her pioneering work on the greenhouse effect, that just came out of the blue. No one ever, and it was a guy who it wasn't even in the chemistry field that he stumbled across her work by accident. So most of these are simply where things happen. You find something, and one of the problems is with the very generous male professors who let these women publish on their own. So you just get an article by J.D. Smith or something, and you don't realize it's Jane Smith, who was a pioneer. But that really helped the work in our book that's just about to be published, where we were able to track down these women that worked with 12 of the very prominent British chemists of the period, and some of whom have been completely overlooked. But the other thing is a lot of them left very few records or none. So this is another factor that we have to keep in mind, is that when we find one, we've got to be able to find something about them apart from just articles that they've published.
Yes. I mean, it's a bit of an issue, isn't it? But as you say, you only get the initial, because I know I was trying to find out who were the earliest black chemists or Asian chemists in Britain, and it was practically impossible because nobody referred to them in any form as black or Asian. And if you've only got the initials, or indeed even the full name to go with, it's often quite impossible. I mean, there was a black chemist I came across recently. Well, quite astounded to find he was black. I've forgotten who it was now offhand, but when I was working on something else, I discovered there was this black chemist in plain view in the early 19th century. It was quite amazing. And the same problem, of course, arises with women. I
Oh,
suppose one way you could try to do it would be, sorry, I'm just typing somebody a message. Um, One way you could try to do it would be looking at university photographs, because in the corridors of at least many British universities, I can't really speak for other universities, you have all these photographs from the 1900s and 1920s and so forth, and obviously there's some women in it. And if you can find out um, who the people are, you could maybe start to work on what they did. It's just one new angle of approach, if it were.
Oh, that's a very good idea, Peter. That's an excellent idea. Yeah, yeah. And in fact, we did that a couple of times. We stumbled across a photo, and there's a woman of the chemistry department of some university of 1900 and something. Well, who is this woman? But another complicating factor is change in names on marriage. It's little known fact that at the time, very few people connected Dorothy Hodgkin with Dorothy Crowfoot, the name she had before she was married. It was, because she published under the name of Crowfoot.
Yeah. That's another problem. Okay, so you've now got this large number of women, well, fairly large number of women. Can you now start to draw any conclusions from that? I mean, for example, which sort of environment were best for women, which country, particularly when you talked about Russia, for example, which countries were particularly supportive of women chemists? Can you now start to make generalizations about why some women chemists succeeded and others didn't?
Yeah, that's a very complex question. But one of the interesting things that in this book that will be coming out shortly is we tried to find out something about the personality of these men chemists who employed them. And with only a couple of exceptions, that things that were said about them, like Ramsay or Tilden or Vernon Harcourt, was that they were, and Garland Hopkins, they were exceptionally kind, very pleasant, and provided a very positive working atmosphere. I think that was very, very crucial that that because of that, then women chemists felt comfortable working with them and were supported by them.
Yeah, yeah. I mean, it would be very interesting to be doing some kind of synthetic work like that, wouldn't it? To look
Oh yeah, yeah.
at women chemists as a group, because you have tended to work more with them as individuals, haven't you? I can perfectly
Oh yeah,
understand
yeah,
that.
yeah, yeah, yeah. Yeah,
Yeah,
well, let's say this book now is the first time when we've got a grouping them by their research group. And some of them moved between these specific research groups because there was this supportive and welcoming atmosphere.
yeah. In fact, Geoff made the point that women's universities in the United States, of course, were one particular source of women chemists, as indeed there were for women astronomers as well, which is something I've been working
Yeah,
with.
yeah. You noticed that the Holyoke College was one that we mentioned. Yeah, and in Britain, one of the sad things is that probably the most common place where women got degrees in chemistry in the early years was Bedford College. And of course, it no longer exists. It got absorbed into Royal Holloway and it sort of seems to have evaporated from the memory. And yet that was more than Cambridge, more than Oxford, was the place where women chemists did their first degree.
Hmm, hmm. Well, of the 12 chemists you dealt with today, who would you say is the most significant? I mean, I suppose it may be a difficult question to answer, but is there one that you would sort of highlight more than any other one?
Yeah, I couldn't comment on that. I'd not put.
Okay, okay, Jeff. Two more comments very quickly. And that is that one person you've never mentioned, as far as I'm aware, but I can't say I've read the whole of your oeuvre, so maybe you've mentioned them somewhere, is Clara Hundecker.
Yeah, that's a good point. But just to mention that we're quite open to adding extra names. It's not limited to 12 forgotten chemists. We can
No.
but
Clara Hundecker might be an interesting one to do.
yeah.
Okay. The other thing, slight comment I would make is you talk about Erica Kramer and gas chromatography, and that's perfectly valid, and obviously you make a good point. But there is a difference here, correct me if I'm wrong, but she works on gas solid chromatography,
Yeah.
whereas James and Martin worked on gas liquid chromatography. I mentioned it because the pioneers of gas solid chromatography were quite different. I mean, another one who was a man well, Courtney Phillips at Oxford, who I actually met at one point.
Yeah,
Yeah,
yeah.
he was a pioneer of gas solid chromatography as well.
That's a very good point. Yeah, yeah. One of the things is that you've noticed going through like Asprey and Bell is this pervasive Matilda effect where when the woman chemist does make a discovery, quite often it gets attributed to the male that she worked with, and that was again the case of Alice Ball.
Yeah. Yeah, somebody, Christine Hodgson say for Curtin Hall, who done a lot of research on Florence Bell. In fact, he's here. I'm asking him to put his question in chat, but Curtin, if you can hear me, would you mind putting your question in chat, please? I think he is trying to ask a question, but I haven't had it yet, I don't think. Okay, so we've got one question here. Were there particular universities or topics of research which were more historically open to female researchers than others? Indeed, obviously, one of those, as somebody mentioned in chat, is X-ray crystallography. And in fact, we had a meeting last October that featured several women chromatographers, generally speaking, the better known one. Have you got any comment on that? Which particular types of chemistry? I mean, interdisciplinary chemistry is a key area, isn't it? Because men tend to avoid those sort of risky sort of areas.
Yeah, yeah. This as we mentioned in one of our previous books, that niche areas were very popular because there wasn't the degree of competition. That quite often it seemed that men were going into areas that were established, where there'd be like organic chemistry, inorganic chemistry, and and particularly not going to bridging fields or multidisciplinary fields where there was no obvious reward or recognition for it.
Yeah. Somebody here asked for bibliography. I don't know. Do you have a sort of bibliography on your website? Could you put the a link to your website in chat so people can look further?
Oh, unfortunately, that my campus got cyber attacked and ransom attacked over Christmas,
Ah,
and the whole site has now ceased to exist. There is no Grenfell campus email system at all. We've had to piggyback off that of the larger campus, and even our email address had to change because the server doesn't exist anymore. It was unsalvageable. So unfortunately, I don't have a web page anymore.
and well, anyway, just dirt on land, folks. Okay, well, thank you very much, Geoff. I don't want to hold you back. It's very early in the morning where you are. And once again, thank you very much for such a wonderful talk. And we look forward one new message, maybe a question. How does the curtain hall? Yes.
Oh
Look,
yes, yeah. Thanks very much. Yeah, yeah. We
as a
were.
co-host, as a co-host, you get all the chat anyway. It's
Yeah,
basically about Florence Bell and all that stuff.
yeah,
And as somebody said, he's doing a lot of work. Of course, he's been doing a lot of work on Asbury as well, so it's obviously a spin-off of that. So maybe worth communicating with him. Okay,
yeah.
thank you, Kirsten, for that. Um,
Okay.
and thank you, everybody, for coming to one of our talk. We had over 50 people today. We look forward to seeing you all again next month when we have a woman talking, Helen Cook, on 200 years of oxygen, the discovery by Joseph Priestley. So hope to see you next month. Thank you very much, Jeff, and goodbye for now.
Okay,
Bye,
thank you.
everybody.
Bye.
Have a nice weekend. Or nice end of the day. Bye.